And Aeternity is one of our newest members, along with Protocol Labs, who's speaking later. So take it away, Sascha. Sascha.
Sorry. So I'm Sascha Hanse. I'm doing the protocol design at Eternity. And this very short talk is going to be just a status quo on Eternity, basically. So Eternity is a smart contract platform. We have made a decision to what we think are critical building blocks for a blockchain to make them native. Meaning that they're built to a protocol. You don't have to build them by smart contracts or anything, but they're just there to make life for developers easier. So that includes state channels, smart contracts, obviously, naming service, oracles, among other things. And everything is built on Bitcoin NG. I think most people here are fairly familiar with Bitcoin NG. Bitcoin NG basically is Nakamoto consensus where the block production and the leader election are distinct, meaning there's a key block that is done for leader election, then the selected leader is, can just produce blocks until the next leader is ready, basically. The good thing about Bitcoin NG is that it gives us very fast transactions. One of the downsides deploying it was that many of the miners are just absolutely not familiar with it and had problems. It was basically a problem of education to get them to run the protocol as it's supposed to be run. Then we have smart contracts. We have both a new programming language and a virtual machine. The programming language is called Sophia. It's a type functional ML-like programming language. It's inspired by Reason. It's from Facebook. And the virtual machine has a really interesting name, but I'm not going to go into this thing. It has tech data, so automatic memory management, associative memory, all instructions, and memory positions are typed and tagged, and all instructions are checked for overflows, unflows, type, etc. Design is done by Eric Stenman, who worked on Scala, Ulf Norell, who wrote Adga, which is a dependently typed programming language, and Robert Verding, who is one of the co-designers of Erlang. The reason why we have our own programming language and virtual machine is because of the earlier mentioned native state channels, names, and oracles, meaning that within the smart contracts, you want to be able to obviously interact with oracles, state channels, and names. So we needed to extend basically the virtual machine and the language to provide access to these sort of first-class objects. So then I'm going to just very briefly talk about those state channels, since Patrick already talked about state channels for I don't know how long, yesterday and today. So what we wanted is a generic solution that supports all smart contracts basically, so it's a poor man's MPC. Even better if the channel is generic, so it can be instantiated once and used for many different smart contracts. Composability, meaning that if a channel works in the case of the direct case from A to B, it should also work from A to C via B. It should be upgradable, meaning even, for example, during a hard fork, the state channel should be able to stay open. The downside sort of this long rigidity of a state channel is that it comes with sort of privacy downturns, meaning that if you open a state channel with someone, you can sort of imply that you're acting that could be bad for privacy, but that's a try to put it on chain. Still, since this obviously every on-chain transaction requires you to pay fees, users should still be careful with whom they open channels. And given the potential for fees and for fees to rise, there's also problems with priority mechanisms. So this is just a very simple overview of what a channel looks like on chain. It's just it looks very simple, but there can be problems. And I think one of the biggest things that we did was not just have this channels on-chain represented, but also off-chain, which is much more complicated. Which is basically just the state machine that handles everything that happens off-chain in a generic way, meaning that you can plug in every application logic at the top, and this thing handles everything between you, meaning the application logic and the chain, which is fairly cool, but also in a generic way very complex. And last but not least, which is a very new thing, is that since making state channels understandable for people is still very, very hard, both for developers and users, we're going to, or started to develop like a playground where you can basically have a self-sustained IDE within which you can test, deploy, and develop state channel applications, which will be released probably in the next couple of months. So now, even though Patrick said state channels are mostly a solved problem, I don't know if I agree, but those are some open questions that I and we have. The biggest one is mostly UX and UI, meaning how do you make that understandable for users? How does a user understand what the code does that is being run inside the state channel, which is obviously a very hard problem. And if there's a generic way of just representing it, or if every application will end up having to build their own UI, basically. Performance verification of the protocols. I started just recently playing with TLL Plus to formally specify the on-chain and off-chain state machines, which already sort of caught one sort of subtle bug in the on-chain state machine. Then verify off-chain contracts that are too big for on-chain, meaning that you can finally do things off-chain which you wouldn't be able to do on-chain, but can still verify them, which might need special VM with special instructions, and incentives for miners once a significant amount of traffic happens in state channels, because if everything happens in state channels, then all of a sudden they have no more fees, CRDTs, meaning state channels will move participants, so you have updatable. It's basically you remove one round from the updates, then start work groups for both on-chain, off-chain, and on-chain to basically remove the free option. Futures I want to skip. Then the last thing I want to say is that we have now starting in January. The Eternity Foundation opens research grants, so if you think any of this is interesting, talk to me and we can get you a grant to work on this. And if you have a startup that you would like to incubate, we have also resources for that. Thanks.
Thank you.
Yes.
So, is Sophia a general programming language, and how much did you have to specialize it for your state channel?
It is not specialized for state channels.
Okay, it isn't specialized.
Ideally, I think it would be great to have a VM that is specialized for state channels, so you can have more succinct proofs of things that happen inside state channels. But the Sophia language itself is not specialized.
And the VM is implemented in what language?
It's Erlang.
Sorry, Erlang?
Yeah.
Okay.
Will it have some performance issue because Erlang is like dynamic type language, right?
Yes.
It probably has some performance issue. Or?
Yeah, that's a bit weird. Your language is statically typed. No, Sophia is statically typed?
Yeah.
So isn't do you have plan in future maybe to go to a static compilation?
As far as I know, we don't. But the thing is, to come back to the first question, sure, it would be better to write in a compiled language, but so far we haven't had major problems with the speeds. Yes.
Isaac?
To be clear, did you mean that it's running on the existing Erlang virtual machine, or that you wrote a virtual machine in Erlang?
Sorry, the virtual machine is written in Erlang.
Yes.
How do you deal with determinism or non-determinism of oracles? If I have an oracle and it provides two different pieces of data,
Yep.
how do you, to validate a contract, you have to run it once again, do you query oracle once again, or how does it work?
The way our oracles function right now is very simplistic, meaning that you have to trust the oracle basically with the answer, which is the current state. We're going to improve that in the future, but right now, if the oracle gives you an answer, you can only give one answer basically, and that's it.
And is it similar to the Ethereum model as far as I understand? I create a query and then sometime next block the oracle promises to call me back with the rate, exchange rate or something.
Well, yeah, sure. The oracle calls you back whenever it has an answer. It could be in the next block, but it calls you later.
Hey, Ty?
Can you say a bit more about this interaction you had with the miners and how you had to educate them and whether this resolved your issue with liquidity?
Yeah, the biggest thing was that the miners, or most of the miners that we interacted with, weren't aware how the protocol works, in the sense that they were just expecting the normal Bitcoin protocol, Nakamoto protocol, where you just have block producer and lead election one go. So the biggest problem for us was to enforce miners to basically mine on the latest microblock, which isn't really a given since the fees are very small compared to the block world at the moment. So there's just no good incentive model that for Bitcoin and G anyway that really incentivizes to work on the latest block. But through basically just education, we got them to work on that, and right now it looks much better.
All right, thank you, Sascha.